Hi, you're watching Floyd Steinberg's YouTube channel, and today, this. This, of course, is the old head OpenCV and Mediapipe for finger gesture detection. In this case, used to control a DAW or an external synthesizer. This caused quite a big stir some 4 years ago, but chances are you've not seen this before. And as you can build this yourself relatively easily for a relatively low amount of money, I'll show you how to do this in today's video. Here we go. Before we get into the details, here's another demo. The left hand controls chords and filter, the right hand plays bass. The room was very dark here. Sound is from the synth. Right, let's take a look at what you need for this. The smallest Raspberry Pi that can run this setup is the Raspberry Pi Zero 2, which costs around $20. In this video, I'm using my Clockwork Pi Cyberdeck though. This is a Raspberry Pi Compute Module 4 based device. You also need an SD card for roughly $5, a USB camera for about $10, and a USB hub for around $10. And that's it. Since you're watching this channel, I'll assume you already own a hardware synthesizer to use with this, ideally one with a USB interface like the synth here. Start by installing the Raspberry Pi operating system onto the SD card using the Raspberry Pi Imager. For this to work, you need the previous version of the operating system, Bookworm. Put the SD card into the Raspberry Pi and connect it to your Wi-Fi. You can attach a keyboard and monitor or simply log in via SSH or VNC. Open the terminal and type sudo apt update, sudo apt upgrade, and then pip install Mediapipe OpenCV Python --break system packages. If you're running Bookworm, this should go through without any trouble. Next, connect the camera and the synthesizer or MIDI interface to your Raspberry Pi. As I mentioned earlier, OpenCV and Mediapipe have been around for a while. They really took off in 2021, and you'll find plenty of tutorials online. This open source software analyzes any video stream and looks for anything vaguely human looking or sounding, breaking it down into mesh models and keywords. OpenCV was developed by Intel around 1999 and Mediapipe was developed by Google in 2017. OpenCV is a library that helps with image processing, drawing, video capture, image manipulation, and so on. Mediapipe is a framework built around neural networks that specializes in object model recognition, faces, hands, poses, and so on. Both are still in active development, but their focus has shifted a bit toward web applications. That's why we're using the slightly older build for this experiment here. You can easily write your own Mediapipe apps in Python. Just open a text editor, type in your code, and save the file as filename.py. Let's take a look at today's example. I won't go through every detail, but I'll give you a quick overview of what's happening. We start by importing CV2, Mediapipe and RT-MIDI, Python libraries that provide all the high-level functions we need. There are a few performance options you can tweak here. For instance, turning off the wireframe display frees up some CPU cycles for other tasks. A Raspberry Pi 5, for example, should be able to process more frames per second, which means faster detection and lower latency. This part of the script scans for MIDI devices and lets you choose one at startup. Then we define 5 chords in the key of C major by their MIDI notes, one for each number of fingers you can hold up. Next, we set up the camera. Mediapipe doesn't need high-resolution images. In fact, it works perfectly well at 160 x 120 pixels. Modern cameras usually output much higher resolutions, so it helps performance to downscale the image before feeding it into Mediapipe. Mediapipe parses the image almost instantly. It then gives you a set of so-called landmarks and their XY coordinates on screen. The function finger up here uses this data. It looks at the 5 landmarks associated with the finger and thumb tips. We simply compare their relative position to the upper finger joints. If the tip is lower than the joint, the finger is down. We loop over all fingers, count how many are up, and that's it. This part of the script checks whether there are hands in the picture, whether they are left or right, and extracts the 21 landmarks for each hand. We then count the fingers on each hand using the function above, and we also record the Y position of the left hand's wrist. That Y position is converted to MIDI CC1, which is the modulation wheel. The number of fingers held up selects notes from the array we defined earlier. We do the same thing for the other hand, but assign single bass notes to each possible number of fingers instead. On the X synth, I now need to assign the mod wheel to filter cutoff, and that's basically the whole script. Here's another fun example. This one tracks my eyebrows and maps them to pitch bend and mod wheel. Alright, that's it for today. I hope you found this interesting. Here's one final demonstration on the Akai MPC Live 3 where I play the chords and the MPC handles everything else. Yeah, and that's it for today. OpenCV and Mediapipe with a $10 webcam and a $20 Raspberry Pi module used for controlling MIDI devices like synthesizers or DAWs. And if you think this was a good YouTube video, please do the YouTube thing. As always, thanks for watching and see you again next week. Bye bye.